Hello, Cincinnati Public Schools Algebra 1 students. This is Mr. Chad Vahue coming to you from Gamble Montessori with the COVID-19 Remote Learning Week 1 answer key. So today I'll talk briefly about the Freyer model using the words algebraic expression and equation. We'll be solving some problems together, and I'll invite you to continue completing the Freyer model as we go through. There are other websites that you can look at here for additional help. Okay, so as you're drawing the Freyer model on your sheet of lined paper, or if you actually have a printout of this, we're going to be talking about algebraic expressions and equations today. Now you can Google these exact definitions. I'm going to leave that for you, but we will be talking about facts and characteristics, basic concepts. We'll be doing lots of examples today, and then perhaps you can come up with some non-examples on your own. I'm going to leave this part to you. I will give you all the other answers in detail as we proceed. Okay, so for fluency, the first question says, in the expression x divided by 5 minus 3, which is the correct order in which operations have been done to x? So this question is talking about order of operations, and sometimes we think of that as PEMDAS, or parentheses, exponents, multiply and divide, add and subtract. And as we are simplifying, we are always remembering that this goes from the left side to the right side. Okay, so as I'm looking at this in my operations, one of the things that I see is division sign. Uh-oh, my tool is lagging. Pardon me for a minute. I see a division sign. See if I can get my tools to. We'll see if that fixes itself here in a minute. Whoa, okay, all at once then. I see a division sign. So in my order of operations, I'm thinking that's here. And then I also see a subtraction symbol, and that would be here. So what I'm looking for in my answers is that the division is going to come first in our order of operations. The addition subtraction is going to come next. So question or part number 1 says x was divided by 5. Yes, x was divided by 5. And the result was subtracted from 3. Now, this little part can be very annoying. The result was subtracted from 3. If the result is being subtracted from 3, then what I'm thinking in my mind is that this came first in order of operations, but the result was subtracted from 3. These two expressions are not the same. Subtraction is not commutative. We cannot write it in any order. So unfortunately, this one is wrong because of the result was subtracted from 3 idea. Okay, so that is not it. Number 2, x had 3 subtracted from it, and the result was then divided by 5. Well, if the subtraction came first, that's going to break our order of operations. So we also know that that can't be the correct answer. If x was had 3 subtracted from it, and the result was divided by 5, we know that this would not be correct. One of the ways that we could guarantee that it's not correct is to substitute in any number we wanted for x. For instance, suppose even though I don't know what x is, this isn't an equation, it's an expression, I'll never know what x is, but I could substitute in x is 10. And if I substituted in x is 10, just as an example, and then I followed my order of operations, I would have 10 divided by 5, which is 2, and 2 minus 3 is -1. Now, if this were equivalent to this, I should still get a -1. However, if I take the exact same value of x and I substitute it in, I now come up with order of operations tells me to multiply first. 10 divided by 5 is 2, and 3 minus 2 equals 1. We can clearly see that this answer did not supply us with the same result as this answer. Therefore, this idea of switching around the 3 and the expression x minus 5 is not going to work for us. So thus far, we have a no from this one and a no from this one. Number 3, x was divided by 5, yes, and 3 was subtracted from the result. 3 being subtracted from the result means that it came next, and I believe that is going to be our final answer. Yes. If we look at this very last one, oh, it got deleted. 5 was divided by x. Well, if 5 was divided by x, we would have this look, 5 divided by x, and then 3 was subtracted. That is also not going to be correct. So our only correct answer is going to be 3. Okay, which of the following is the solution to 6x plus 1 equals 4? Show the steps or explain how you found the solution. All right, this is an equation. Above, we were looking at an expression. An equation has an equal sign, and what I like to do with my Algebra 1 students is build walls around that equal sign. When we solve an equation, we are going to be undoing the order of operations. So we're going to go in the exact opposite order. And we're going to undo by doing the opposite operation. So the very first thing I do when I look at an equation is I find my unknown value. And I think, okay, I have a number that's being multiplied by 6 and 1 is being added. I wish to undo my order of operations. To solve this, I'm going to undo the plus 1 with a minus 1. I'm going to do that on both sides to maintain balance of my equation. 1 minus 1 gives me 0, and I now have 6x plus 0, or simply 6x equals, and 4 minus 1 is 3. All right, I have undone my addition subtraction, so I'm going to move on to my undoing of multiply and divide. I'm going to be using my opposite operation. So the opposite of 6 times x would be to divide by 6. In order to divide, I'm going to use a fraction bar to show division. So I'm dividing the left side, and I'm also going to divide the right side. 6 times x divided by 6. Well, 6 divided by 6 is simply 1, and 1 times x can be written as x equals, and 3 divided by 6 is 1/2. Now, maybe as we type that into a calculator, we could also see that this would be 0.5. However, I like 1/2. All right, and as I look over here, I'm looking at all of my different answers, and I'm realizing that it is choice 2. Moving on. The solution to 5 times the quantity x minus 2 minus 6 equals 24 is which of the following? Show the steps. Okay, so my steps are going to be number 1, simplify, and number 2, undo the order of operations. In order to simplify, once again, I'm going to build my walls. And I am going to simplify the entire left side. Lagging again. I'm going to simplify the entire left side of the equation. Now, there's a lot of ways we can actually solve this equation. I'm just waiting for my pen to catch up to me. I could add 6 to both sides and then divide both sides by 5. Some math teachers would tell you to go ahead and do that, but I'm just going to be teaching one set of steps, and that one set of steps will be to simplify the entire left side of the equation first. Little pen tool. Let's keep going. Waiting for that to stop thinking. Okay, here we go. Okay, so the first thing I'm going to do is I'm going to distribute. 5 times x is 5x minus 5 times 2 is 10, and then we have a minus 6. I'm going to keep writing equals 24 just to rewrite my equation every single time. Okay, now I have a 5x minus 10 minus 6. I'm going to go ahead and change minus to add the opposite each time I see it. So as I rewrite this to simplify both sides, I'm going to have 5x plus negative 10 and a negative 6 gives me a negative 16 equals 24. Okay, now this expression, 5 times the quantity x minus 2 minus 6, is now written in what I call simplest form. I have no more like terms that I can combine, and I'm ready to then go ahead and begin the undoing of the order of operations, step 2. So I'm going to attack my addition subtraction first, and then I'm going to move on to attack my multiply and divide second. Because solving equations involves undoing those order of operations. Okay, so I'm going to attack the addition subtraction first. I want this to become 0, and in order to make negative 16 into 0, I'm going to add 16. I'm going to do the same thing to the other side to maintain the balance of my equation. So now I have 5x plus negative 16 plus 16. Well, a negative 16 and 16 are 0. 5x plus 0 gives me 5x. And then on the right side, I have 24 plus 16, which is 40. So I have attacked my addition subtraction. I'm going to move on to attacking my multiplying and dividing. I can see in my equation 5 times x equals 40, so I'm going to attack that times 5. In order to get rid of that, I'm going to do the opposite of multiply. I'll divide. I'll use my fraction bar to show division. And I'll maintain balance of the equation by dividing the other side by 5 as well. 5 divided by 5 is 1, and 1 times x is x equals 40 divided by 5 is 8. So this is my final answer, x equals 8. And as I look, I can see that it is choice 4. I should also mention that we could take x equals 8 and substitute it right back up into this x value right here, just to make sure that we got the answer right. 8 minus 2 is 6. 6 times 5 is 30, and 30 minus 6 is 24. So my check, using my order of operations in the correct order, is going forward as I am simplifying, is going to give me confidence that I got the answer right. Okay, number 4, if a number is increased by 5, well, okay, it doesn't tell me what the number is, but that number is increased by 5, and the result is then divided by 3. There's a few ways I could write this. I could write it like this. Doesn't really look like something I'm used to solving. It's fine, but I don't think I want to solve it looking like that. So I'm going to instead write it slightly differently. Uh-oh, that wasn't an eraser. There we go. I think I'm going to write, if a number is increased by 5 and the result is then divided by 3, I think I like this look better. It looks more like equations I've seen many times. The result is 7. Write an equation that models this verbal description and solve the equation for the number described. Okay, so I have a number increased by 5, the result divided by 3, and the result is 7. So I'm now going to think about PEMDAS once again. And in my classes, I don't actually call it PEMDAS because this P parentheses is not always descriptive enough. I like to put a G there for grouping symbols. This x plus 5 is in the numerator of a fraction, and when it is actually grouped in an understood set of parentheses. So what that means is, even though undoing order of operations would tell me to attack the addition, subtraction, attack the multiply and divide, the P parentheses, or G, if we're using G in PEMDAS, means that this is going to come later on. In order to solve this equation, I must first attack that divided by 3, because undoing that means that the multiply divide is coming before the understood set of parentheses or the grouping symbol. So in order to attack this divided by 3, I'm going to multiply both sides by 3 to maintain balance. Oh, almost forgot to build my walls. Okay, 3 times the group divided by 3 is simplified as 3 divided by 3 is 1, which leaves me simply the group of x plus 5. equals 7 times 3 is 21. You'll notice I dropped the parentheses because I no longer need them. They're not separating x plus 5 from anything, so I'll leave them off. I'll now go through and subtract 5 on both sides. 5 minus 5 is 0, and x plus 0 simply is x equals 21 minus 5 is 16. That is our final answer. As always, I can take x equals 16, substitute it back in up here for x. 16 plus 5 is 21, and 21 divided by 3 certainly gives us 7. So we know we got the answer right. All right, Max and his friend Zeke are comparing their ages. They figure out that if they double Max's age from 3 years ago, Max from 3 years ago has his age times 2 or double. So I am putting in these parentheses to say that the first thing we're going to do is subtract 3, and then we're going to double it. They figure out that if they double Max's age from 3 years ago and add to it Zeke's current age, so all of that plus Zeke's current age, the sum, here's my sum, is 26. If Zeke is currently 8 years old, okay, well, that's telling me that I can substitute in 8 for Z. Determine how old Max currently is. All right, so I assigned a variable. I assigned M to be Max's age. And so now I have this doubling Max's age from 3 years ago. Adding to that, Zeke's age, which we found out was 8, should be 26. All right, so what are my steps? My first step personally is to simplify. Simplify, if I can spell that correctly. And then we will work on undoing the order of operations. Addition, subtraction. Okay, so we could minus 8 on both sides, divide by 2. We could do that. Some teachers would teach students to do that, but I'm going to follow this idea of distribution. 2 times m is 2m, minus 2 times 3 is 6, plus 8 equals 26. I forgot to build my walls again. Okay, again, because I'm dealing with subtraction, I'm going to change this minus sign to adding the opposite, and then I'm going to rewrite one last time. 2 times m plus negative 6 plus 8 is 2 equals 26. And now I am done with my simplifying. In this line, I now have simplest form. All of my like terms have been combined, so all of my simplification is done. And now I'm going to attack my addition subtraction first. The opposite of plus 2 is minus 2. I'll do that to both sides. Maintain balance of my equation. 2 minus 2 is 0, and 2m plus 0 gives me 2m. 26 minus 2 is 24. And now I'll attack my my multiply divide. The opposite of times 2 is divide by 2. I'm going to use that fraction bar to show division. I'm going to maintain balance by doing it to the other side. 2 divided by 2 is 1, and 1 times m can be written as m equals 24 divided by 2 is 12. So with m equals 12 being my final answer, it looks like Zeke is 8. Find out how old Max currently is. I think Max is 12. Okay, which equation is equivalent to the equation 6x plus 9 equals 12? There's a couple of different ways we could solve this. One way that we could do it is simply to attack the addition subtraction. We're going to solve the equation. I'll minus 9 on both sides. 9 minus 9 is 0, and 6x plus 0 is 6x. 12 minus 9 is 3. Look at me not building my walls again. Okay, and then to undo this times 6, attack or addition or multiply divide second, I will use that fraction bar to divide 6 on this side and divide 6 on this side to maintain balance. 6 divided by 6 is 1, and 1 times x is x. equals 3 divided by 6 is a half. You could also write x equals 0.5, but fractions are my friends. I'm going to go with x equals 1/2. So the question is, which equation is equivalent to this? Well, one thing I could do is just take this x equals 1/2 and then substitute it in. So my x value is now a half. Does a half plus 9 equal 6? No, certainly not. A half plus 9 is 9 and a half, and that does not equal 6. So does this answer work in this equation? No, it gives us a false statement. If it gives us a false statement, then the equations are not equivalent. Equivalent equations should have answers that balance each equation, such as with x equal to be 1/2, 6 times a half is 3, and 3 plus 9 is 12. So 1/2 gives me a balanced equation. A half does not give me a balanced equation here. I know it's wrong. Let's try this one. 2 times a half plus 3. Well, 2 times a half is 1, and 1 plus 3 does equal 4. So this works. Moving on. 3 times a half is 1.5, and 1.5 plus 9 is certainly not 6. It's 10.5. 10.5 is not the same thing as 6, so I know that's the wrong answer. Last but not least, 6 times a half. Well, half of 6 is 3, and 3 plus 12 is 15. 15 is not equal to 9, so I know 1/2 does not work there either. So what I did was I solved this equation by undoing order of operations. Once I got the answer, I substituted it back into each of these equations to find out that it only worked in choice B. Is there another way? Certainly. The other way, that is probably quicker, would be to divide the entire left side by 3 and the entire right side by 3. If I divided the entire left side by 3 and the entire right side by 3, I might notice something that matches up over here. Now, when we have 6x plus 9 divided by 3, we have what we call a compound fraction because there is a plus sign right here. Another way that we can write a compound fraction is by giving each part of the numerator, I could say each term in the numerator, its own denominator. Well, I should say divided by 3. 12 divided by 3 is 4. So I'm using a property of fractions that says a compound fraction may be broken up so that each term in the numerator has its own denominator. 6 divided by 3 is 2, so I would have 2x. 9 divided by 3 is 3 equals 4. And this perfectly matches this. So perhaps option 2 is a faster option. Now, how did I know to divide the left side and the right side by 3? Well, I noticed that 6, 9, and 12, which was the coefficient and the two constants in this problem, all had a greatest common factor of 3. And anytime I notice that the coefficient and the constants of an equation all have a greatest common factor greater than 1, I know that I can simplify by dividing the left side and the right side by the greatest common factor. So that's just one of those tricks that popped into my head. This is more of a fallback measure. It takes more time, but it always works. So it's a good one to use. Your choice. Okay, select all the equations that have the same solution as this equation. All right, so we are going to once again solve an equation by undoing order of operations. Therefore, I am going to attack my addition subtraction first. I'm going to undo the minus 12 by adding 12 to both sides. So I am now left with 3x minus 12 and plus 12 is 0. 3x minus 0 is 3x. Build those walls. 24 plus 12 is 36. Okay, so I've attacked my addition subtraction. Now I attack my multiply divide. I'm going to look at this times 3 and undo times 3 by division. Once again, using that fraction bar to show division. I'll divide the left side by 3 and divide the right side by 3 to maintain balance. 3 divided by 3 is 1, and 1 times x is x equals 36 divided by 3 is 12. I could substitute this back in, but I'm confident I did this correctly. So now I know x is 12. Select all the equations that have the same solution. Okay, so as I went through and solved these previously, I noticed that this, by adding 60 to both sides and dividing both sides by 15, gave me x is 12. If I divided both sides by 3 here, I would see that x is 4. If I divided both sides by 3 here, I would see that x is 12. If I added 4 to both sides here, I would notice that x is 12. And if I added 12 to both sides and then divided 12 on both sides, I would notice that x is 3. So I'm looking for something that has the same solution. That's giving me choice A, choice C, and choice D. And that is the end of week 1. So friends, I hope you got something out of this. We did look at algebraic expressions. We did look at equations. Maybe you noticed some facts and characteristics about algebraic expressions and also about equations. Maybe you can go through and find some examples of expressions and equations, some non-examples, and come up with a basic concept here to complete the Freyer model. Okay, if you have any additional questions, you can go to Khan Academy, maybe looking up those in algebra or these other helpful websites. And that concludes week 1. Take care.